So, good morning, everyone. I hope I'm sharing my screen. Oh, I'm not sharing my screen, so I should share my screen first. Good morning, everyone. Meanwhile, I share the screen. This is a new topic, and as I told you, this is wave optics, lecture number one. I hope. Where is my thing? I hope this is visible to all of you. Wave optics, lecture number one. And we are dealing with interference. That is the first topic that we are going to deal here. Now, as I told you up till now, we were in ray optics, and in ray optics, we could have treated light as a particle or as a wave. Both of these things will justify ray optics, light moving in a straight line, getting reflected or getting refracted. But there are some phenomena we have already discussed. Light has a dual nature. Yes or no? There are some phenomena which can only be described by the particle nature of light, namely photoelectric effect. Then there are some phenomena which can only be described by taking the wave nature of light. And today we are starting with something known as interference, which is the first phenomena that can be described only by the wave nature of light. So without taking much time, let me switch to the next screen, and the next screen will come right away. So the next screen is here. I hope you can see this. Okay, I need to make some adjustment here. Just give me a moment. Yep, it must be visible to you now. Interference of light. Have you heard about this term, interference of light? No? Okay. Have you heard about this term, superposition of waves? Have you heard about this term, superposition of waves? Yes, you have heard about superposition of waves. So this phenomena can be understood. Let me just adjust this once again. This phenomena can be understood by the principle of superposition. And let me highlight that for you. This is again from your sheet. Do we have those sheet with you now? Okay, that's great. Everything works out in the end. Superposition. Now, if I just tell you what is superposition, I hope you have seen, for example, I have two waves. The first wave is y1 is equal to a1 sine omega t. That is my first wave. I hope everyone is noting it down. And my second wave is y2 is equal to a2 sine omega t plus phi. I think we have discussed this before. Yes or no? We have discussed such equations before. Okay, this y1, this y1 is the displacement of the particle as a function of time. And you must be thinking why I'm smiling, because I see some student only saying yes when she sees the other student saying yes, just to be sure that we have done this. Okay, I would not name that person. Y1 is the displacement of the particle as a function of time. So you just put the value of time here. As you can see, what is this t standing for? This t stands for time. Yes or no? Do we understand this? Okay. This y1 is the displacement of particle number 1, wave number 1, as a function of time. What is this a1? I know you can't say because you don't have a microphone. This a1 is the amplitude, maximum displacement from the mean position. Do we remember this? A1 is the amplitude and this omega is the angular velocity. Now, instead of calling it angular velocity, we are going to call it angular frequency. Omega, 2 pi f. F is the frequency, 2 pi by t. Do we remember omega? Should not forget omega anytime soon. Now, this is my first wave, which is denoted by y1. The second wave is denoted by y2 with double arrows. Similar things happen with double arrow thing. Y2 is the displacement of the particle, second wave, as a function of time. A2 is the amplitude of this wave. Omega, now remember here what I have done, and please note it down very carefully. This omega for both the waves is same. Do you see this? I have not written omega 1 and omega 2 because I wanted to make both the frequencies or angular frequencies same. Therefore, the value of omega is same. The value of omega, which is in yellow, is same, but you can also see that some things are different. What are those things that are different? If I can select this. Okay, what are the things that are different? As you can see, oh, the color has not changed. I will have to try again. Let me try it again. There are some difficulties. Sometimes everything is a software, and the software sometimes gives me trouble. So what I need to do is I need to readjust this. I need to bring this here so that I can change the color nicely. Okay, now the color is changed. Okay, so I come back to the screen. Yellow, I have highlighted things which are same, and with blue what I have highlighted is things which are different. Can you see that the amplitude of the two waves are different? Amplitude of wave 1 is a1, amplitude of wave a2 is a2. Now, if I highlight this entire term which is inside this sign, whatever is inside a sine or cos or tan is definitely an angle. It has to be an angle. You can only find sine or cos or tan of an angle. You cannot find sine and cos of anything else. It has to be an angle. Now, this angle in blue, whether it is omega t plus theta or it is simply omega t, this angle is known as the phase of the wave. Do we remember this word, phase? This omega t or this omega t plus phi is the phase of the wave. Now, when you look at the phase of the wave, the phase of wave number 1 is omega t, but the phase of wave number 2 is omega t plus phi. Am I making sense? Do we understand, students in the class, that the phase of wave 1 is omega t and the phase of wave 2 is omega t plus phi? Now you can see very clearly, one thing in both the waves is same, and that same thing is that they are having the same angular frequency. But if I talk about the phase of these waves, they do not have the same phase. Do we understand this? Phase of wave 1 is omega t and phase of wave 2 is omega t plus phi. They are not in the same phase. Now, if waves are not in the same phase, that means someone is ahead, someone is leading ahead, and someone is behind, lagging. Someone is leading, someone is lagging. Someone is ahead, someone is behind. Now, which wave do you think which equation do you think 1 and 2 is ahead and which is behind? It is very evident. You can see it from the from your screen. Which wave is ahead and which wave is behind? Can you tell me which wave is ahead and which wave is behind? Which wave is ahead? Let me ask you this. Which wave is ahead here? Which do you think is moving forward? I mean, moving compared to the other wave, it is ahead. This is just like race between two people. People number one is Y1. People number two, person number two is Y2. Someone is ahead and someone is behind. Who is ahead and who is behind? Wave number one, is it ahead or is it behind? Let me ask you this way. Which wave is ahead? 1 or 2? Which wave is ahead? Wave number 2. That is the correct answer. Wave number 2 is ahead, or this wave is leading. As you can see, there is a +5 wala sign here. That means this wave is ahead. Do we understand this? This wave is ahead. This wave is leading. Can I have raised hands from everyone in the class that we understand this? Wave number 2 is ahead. Wave number 1 then becomes your wave which is behind. So we will call wave number 2 as lagging. Do we understand this? So instead of calling wave number 1 as ahead, we can also call, instead of saying wave number 2 as ahead, we can also say wave number 1 is lagging. Do we understand this? Now, if I just make a small change, for example, if I just, instead of a plus sign, if I put a minus sign here, the brown one, instead of a plus sign, if I put minus sign, and then I ask you the same question, the question has changed. Instead of wave number 2 being omega t plus phi, wave number 2 has become omega t minus phi. Now, if I ask you, which wave is leading? Wave number 2, the equation has been changed. It has become omega t minus phi. Which wave is leading now? Which wave is ahead? Now, in this case of brown, wave number 1 is leading and wave number 2 is lagging. Do we understand this, bacha? So just by looking at the equation of the two waves, Sai, Kajal, everyone is there? I can not see the other two folk. Okay. In case of the brown equation, wave number 1 is leading, wave number 2 is lagging. You will have to note this down. This is not given in your sheet, beta. You'll have to note this down, and I'll give you a minute. Everything is understandable here. Wave number 1, wave number 2, omega is same, amplitudes are different, and phases are different. They are not in the same phase. If wave number 2 is omega t plus phi, it is leading. If wave number 2 is omega t minus phi, it is lagging. Then the next question is, by how much angle is it leading or lagging? By how much angle is it leading or lagging? By how much angle is it leading or lagging? Then the answer is simply, in the case of the red one, it is leading by an angle of phi. In case of brown one, it is lagging by an angle of phi. Do we understand this? In case of the original equation, y2 is leading y1 with a phase angle of phi. In case of second case, omega t minus phi, y2 is lagging y1 by a phase angle of phi. Can I have some raised hands from everyone that we have understood this? I'll give you a minute to note it down. I'll rub this off and then we will move ahead in life, because in life we have to always move ahead. I'll give you a minute to note it down. Let us move ahead. Now, what is the next thing? We have understood that there are two waves. And now, imagine here, sound is also a wave. Now, what you can hear right now, I am very sure is my voice. But at the same time, if anyone else speaks, you would be able to hear that one out as well. Yes or no? That means two waves, when they are traveling in the same medium, you can make out which wave is which. Now, sound is also a wave. Now, if this sound which I am creating is reaching your ears, and the sound which the fan is creating is reaching your ears, and the sound which is nearby is reaching your ears, that means all these waves are traveling in the same medium, traveling in the same room that you are sitting. Do we understand this? Now, when they are traveling in the same medium, what are they going to do is they are going to intersect, or they are going to superimpose each other. They will be overlapping each other. Yes or no? You can call this overlapping as superposition. You can call this overlapping when two waves are traveling in the same medium as superposition. Now let me go back to my two original waves, and if I remember, my two original waves where y1 was equal to a1 sine omega t and y2 was equal to a2 sine omega t plus phi. I hope everyone is paying attention. Here, wave number y2 is leading, wave number y1 is lagging. Now, they are traveling in the same medium, in the same direction. What will happen? Y1 represents the displacement of particle in the first wave. Y2 represents the displacement of the particle in the second wave. But this particle, let us say this is the particle. Due to wave number 1, it is getting displaced. Due to wave number 2, it is also getting displaced, because particle is the same, because the medium is the same. Do we understand this? Same particle is experiencing both the waves. Same particle is experiencing displacement because of both the waves. So what is the net displacement of the particle? If I call the net displacement of the particle, that will be equal to y1 plus y2. Do we understand this? When you add this, that means these two waves are overlapping each other, or these two waves are intersecting. Overlapping and intersecting are not the right words. The right word is given to you in yellow. What is that right word known as? That right word is known as superposition of waves. Do we understand this? Well done, my dear friends. Now, when you superimpose this wave, what you got to do is you got to add this wave with this wave. Now, that is all about maths, how you add these waves. What are we going to do is to understand. What are we going to do is to understand what result we get. So when I add this y1 and y2, the result I would get would be a wave which would look like this. And please note it down, it is not in your sheet. This wave will look like this. A. Remember, this A is the amplitude of the new wave that is created. It is not a new wave that is created. It is the displacement of the particle which is now experiencing displacement by the two waves. This is the amplitude of that displacement. Do we understand this? This A is the new amplitude. Since the original waves were in sine, the new wave, the new displacement is also a sine wave into omega t plus xi. This angle has changed. Do we understand? Xi is also a Greek alphabet. Why? Xi is also a Greek alphabet, and it is written like what do you call this? Trident, Trishul. Look like that. This is the new displacement of the particle. Here, my dear friends, this A is the total, is the new amplitude of the particle. Do we understand this? And the value of this A is now highlighted in your sheet. The value of this A is A1 square plus A2 square plus 2 times A1 A2 cos phi. Iska root, that is your value of the new amplitude. Do we understand this? Can you note it down? Now, as you can see, this new wave, the new displacement that is created, if I compare it with the first wave, oh, bad. If I compare it with the first wave, this wave, the new wave, if I compare it with the first wave, is the new wave leading or is the new wave lagging? For leading, you say 1. For lagging, you say 2. This new wave, is it leading or lagging from the first wave? Leading is 1, lagging is 2. This new wave is leading. Do we understand this? The amplitude of this wave, I have already highlighted. The amplitude of this wave is A1. Here A1 is written in small. We can write it in capitals. A1 square plus A2 square plus 2 times A1 A2 cos phi ka root. That is the value of A. Now you should also know the value of this xi. You should also know the value of this xi, which is the new angle. And I shall give you the value now. The value of this xi, tan of this xi, tan of this angle xi. Remember, xi is an angle. Tan of this angle xi is A2 sin phi divided by A1 plus A2 cos phi, where phi is the phase difference between the two waves. Do we understand this? So these are the things that you will add. When you add up these two waves, we call it not as addition or overlapping or intersection. We call it as superposition, and you get a new displacement. The amplitude of this new displacement A is A1 square plus A2 square plus 2A1 A2 cos phi ka root, and the angle it makes, tan xi, the angle it leads, xi. Tan of this xi is A2 sin phi upon A1 plus A2 cos phi. I'll give you a minute to note this entire thing down. Please note it down very carefully. It is not given in your sheet. See, beta, when a question comes in the exam, it may be asked in a different way. Now, we have seen how we write the equations for the two waves in words. Now, I'll try to illustrate the same thing in terms of a diagram. We call it the phase diagram. What do we call it? We call it the phase diagram. So what do I do? The lagging wave, I draw first. This is my wave y1 equal to a1 sine omega t. So I've drawn it like this. Now remember, I've drawn it like a vector. Can you see this? It is drawn like a vector. Yes or no? Well done. Then I draw the second wave. Now this wave is ahead by a phase angle of phi. Do we understand this? This becomes my wave y2, and the value of, or the formula for the wave y2, if you understand, is a2 sine omega t plus phi. Can I have raise hands from all of you? This is the way in which the waves are drawn in terms of vectors. Let us not call them vectors because they are not vectors, but they are behaving or adding like vectors. They are waves. Now, when I add these two waves, I get a resultant wave or resultant displacement, and that I'm going to show you with my favorite color blue. And this wave will go here. This is the resultant wave Y. And it makes how much angle with the original wave? Wave number 1. It makes the angle xi. Do we understand this? This is how the diagram is drawn. Now remember, this y is the addition of y1 and y2, and therefore this formula looks exactly same as the formula for addition of two vectors. Do we understand this? Why this formula is looking same as the formula of addition for the two vectors? Because bacha, these two waves are getting added like vectors. These two waves are getting added like vectors. These two waves are getting added like vectors. I will give you a minute to draw this, then I will move ahead. Let us move ahead, and the next heading that we are having is interference of light. Now, many a time students get confused between what is superposition and what is interference. Now, remember, interference, when we use the term interference, it is a very special case of superposition. You can take it this way, you can understand it this way, that interference is a very special case of superposition. Now, superposition can happen for any type of wave. For any type of wave, that means when these waves are traveling in the same direction, when these waves are traveling in opposite direction, in any direction, they may have same amplitude, they may have different amplitudes, they may have same frequency, they may not have same frequency. The fan that is creating noise is having a different frequency. The way I am talking to you is a different frequency. So superposition can happen in all these cases. Superposition does happen in all these cases. But for one particular case, if this superposition happens, that type of superposition is known as interference. Now, what is important about this term interference? When two light waves, please remember, having same frequency, the most important term here is same frequency. Do you understand that omega, angular frequency, it has to be same. The angular frequency has to be same and nearly equal amplitude. So amplitude should not be very different. When we said A1 and A2, the amplitude of the two waves, they must not be very different. They must be very equal. So these are the two conditions that we have put. What is condition number 1? Condition number 1, that they must have same omega or same frequency. Do we understand this? Can I have some raised hand? Because this definition can come as question in your exam. Then the second case is they must have equal or nearly equal amplitudes A1 and A2. The value of A1 and A2 must be very same or very equal. And the third condition is what I am going to highlight next, and moving in the same direction. So that is the third condition. They must be moving in the same direction. If these three conditions are met and this wave superimpose, the word is superimpose, then what happens? The intensity of light is maximum at some point and the intensity of light is minimum at some other point. At some point you have maximum intensity or maximum amplitude. At some point you will have minimum intensity or minimum amplitude. This phenomena is known as interference of light. You are just supposed to write whatever I have highlighted and 1, 2, 3 points. First you will write this and then we will proceed any further. Do we understand this? Three conditions must be fulfilled. Condition number one, same frequency or omegas. Number two, amplitudes must be nearly same. Number three, they must have the same direction. They must be moving in the same direction. Please note this down. I will give you a minute. Very important points. You might not get any numerical or interference, but you will get theoretical questions here. So I'll give you a minute to note it down. Then we move ahead. So you have noted down the highlighted part. Now, when this wave superimpose, you will get a wave, or you will get a new displacement, a new amplitude. The value of this new amplitude is a1 square plus a2 square plus 2 times a1 a2 cos 5 ka root. We have already seen this. Yes or no? No or yes? So you will get this resultant amplitude. A is the resultant amplitude. Now what you got to understand, that intensity of a wave is directly proportional to amplitude ka square. If I make amplitude 2 times, intensity becomes 4 times. Do we understand this? Intensity of a wave is proportional to A square. This is a very, very important result that you must remember. You can get a direct question based on this. Intensity of a wave is directly proportional to its amplitude square. Now, if I write this formula number 1 in terms of amplitude, formula number 2 will become the same formula but in terms of intensity. Please note down this formula very, very carefully, because you might make a mistake in writing it and then you will make a mistake in marking the right option. So formula number 1 is the formula of the resultant amplitude. Formula number 2 is the same but written in terms of intensity of the wave. Remember, here phi is the phase difference between the two waves. I1 and I2 are the intensities of the two waves. Do we understand this? This is what you need to note down. I'll give you a minute to note it down and I will move ahead. Okay then. Now there comes a point where we have understood phase difference. Yes or no? Now phase difference is normally denoted by delta phi or phi. Delta meaning difference, phi meaning phase. So normally we write phase difference as delta phi. Now, phase difference, and then you have delta x. This delta x is known as path difference. Do we understand? Difference in path. For example, this is the source S. Then there are 2 points A and B. Now please try to understand what I am doing. S is the source. I am creating a wave. Now when this wave reaches point A, it will have different phase. When the wave reaches point B, it will have a different phase. Yes or no? Phase A will be different, phase at B will be different. The difference between the two phases is known as phase difference. As you can see, point A is at a distance x1 from source, point B is at a distance x2 from the source. So they also differ in path. They are not at the same place. They also differ in path. This difference is known as path difference. Do we understand this? Similarly, there is something known as time difference. The wave will not reach point A and B at the same time. Yes or no? If it reaches point A at time t1 and it reaches point B at time t2, t2 minus t1 will be known as time difference. Do we understand this? Phi 1 minus phi 2 will be known as phase difference. Phi 2 minus phi 1 will be known as phase difference. X2 minus x1 will be known as path difference. and T2 minus T1 will be known as time difference. Do we understand this? Then these three things are related to each other and the formula is very nicely given here, but I will just write this formula in my language. The formula is given in the bracket. So the formula goes like this: phase difference divided by 2 pi. 2 pi is 360 degrees, but we don't write it in degrees, we write it in radians. Phase difference divided by 2 pi is path difference divided by lambda is equal to time difference divided by the time period. So basically what it is saying, if you remember a wave beta, if I just draw a sine wave, do you remember this sine wave? Yes. So from this sine wave, you can understand how this relation is achieved. If this is the first point, after this point, the wave gets repeated. If I talk about time from here to here, how much time the wave takes to go from point A to point B, the time will be the time period of the wave, capital T. Yes or no? This is the capital T which has come here. Now, if I call the distance between point A and B, the distance between point A and B will be lambda, which is the wavelength of the wave. Do we understand this? And if I talk in terms of angle, if angle at point A is 0, angle at point B will be 360 degrees. The wave will come back after rotating a complete circle or a one cycle. Do we understand this? So from here comes the angle 2 pi. If I write everything together, which I will be doing in the next diagram to make you understand this particular relation, right now I will give you a minute to write this relation and then I will try to make a bigger diagram and make you understand how these three things are related to each other. I'm expecting that you might get a question based on this. I'll give you, as always, a minute. And as Terminator says, I will be back. Then let us move ahead. And as I told you, I will try to draw all things in a diagram and probably then I will try to make more sense. So here the diagram comes. I'm going to draw a wave. This is one full wave. Do we understand this? This is one full wave. Now, if I write 0 here, if I talk in terms of lambda wavelength, the total distance from this point here to this point here would be equal to lambda. Do we understand this? This is equal to one wavelength. Do we understand this? If I write the same thing in terms of time, the particle will take one complete time period to go from the first point to the second point. Do we understand this? So in terms of length, it is lambda. In terms of time, it is capital T. In terms of angle, it will rotate by an angle of 360 degrees. So in terms of angle, it will become 2 pi. Do we understand this? If I talk about this point, the length from or the path length from origin to this point would be lambda by 2. Do we understand this? How much time it will take to go from O to this point? It will be total time period divided by 2. Do we understand this? Similarly, how much angle it would have turned in going from O to the third point? It will turn to an angle of 180 degrees, which is equal to pi. Do we understand this? Let me add two more points to make my point very clear. If I talk about this point here, the brown one, what will be the value of length? How much length it has traveled or how much is the distance from O to A in terms of length? It would be equal to lambda by 4. Do we understand this? In terms of time, it will be T by 4. Do we understand this? And in terms of how much angle it has turned, look at the sine wave. It is 0 and now it is maximum. So it has turned through an angle of pi by 2, which is 90 degrees. Do we understand this? If I give you one more last chance to redeem yourself, if I talk about this green point, how much distance it would have moved from O to this point? It would be 3 lambda by 4. Do we understand this? Do we understand this? One section is lambda by 4, then lambda by 4, then lambda by 4, then lambda by 4. So up till green point, it will be 3 lambda by 4. Can I have raised hands from everyone? In terms of time, it will be 3t by 4. Yes or no? In terms of angle, it would be equal to 3 pi by 2. So from here, you can understand how this relation comes. Have you understood this relation? Okay, I'll give you a minute to note this down. Then I will make a question on this so that you are able to solve it and get it in your head. A minute to win it, as I always keep on saying. Okay, then just to be sure, I'll give you a small question and I hope you can solve this question. Path difference is given as lambda by 3 between two waves or 2 points of the same wave. Path difference is lambda by 3. Lambda is the wavelength. You have to find the phase difference delta phi and the time difference delta t. Can you do it for me? Question number 1. Phase difference is given to you lambda by 3. You have to find me what is the path difference is given to you lambda by 3. You have to find me the phase difference and the difference in time. Can you do that for me? I'll give you a minute to do it. Okay, then it is my humble duty to tell you how the answer is. I just have to apply this formula. Phase difference delta phi divided by 2 pi is equal to path difference delta x divided by lambda. If I put the value of path difference, it is lambda by 3. So it is lambda by 3 divided by lambda. Lambda and lambda gets cancelled. So my phase difference, becomes 2 pi divided by 3. Is it so difficult to do? Is it so difficult to do, bacha? Did I do anything different? I use this formula from here to here to get the answer. Do we understand this? Now, can you redeem yourself and find me the time difference? Can you do that for me now? Can you find out the time difference for me? I'll give you a minute to redeem yourself. You are like cash cards. You can redeem yourself. You have 1 minute to redeem. Well, to find out the time difference, remember path difference is given to us. Path difference is given to us. We have to find the time difference. So we use this part of the equation. Do we understand this? We will use this part of the equation. Path difference divided by lambda is time difference divided by t. So I just noted down path difference divided by lambda is time difference divided by capital T. How much is path difference? Path difference is lambda by 3. Lambda by 3 divided by lambda. is equal to time difference divided by capital T. Lambda, lambda gets cancelled. Time difference becomes T by 3. Do we understand this? Yes or no? No, yes. I'll give you one more question on this because I want you to do this, understand this, because it is going to be very important. You might get a question here on this, and that is why I am putting, because this question is, the question that we are doing is just not a part of interference. It is a part of simple harmonic motion. It is a part of wave. It can come from different chapters. The question remains same. So I'll give you one more. Will you be able to do this now? Do you have the confidence? In now this question, phase difference is given as pi by 3. So I've changed the question. I am now giving you the phase difference, and now I am asking you what is the path difference only, not the time difference. Okay, you can also find the time difference. If you find the path difference, you can definitely find the time difference. And I'm hoping that you can solve this. I'll give you a minute to do it. So how do we go about solving this question? I hope everyone has done this. I am just going to use this formula, whether it is in this form or this form. So phase difference delta phi divided by 2 pi should be equal to my path difference delta x divided by lambda. Do we all remember this formula? Please raise hands. We just put the value of phase difference. Phase difference is pi by 3. Pi by 3 divided by 2 pi. So this becomes simply 3 multiplied by 2. That must be equal to delta x divided by lambda. If I solve this simple equation, I will get the value of delta x, and the value of delta x that I will get will be lambda by 6. Yes or no? No or yes? Kajal, did you get the answer? Is it a yes or is it a no? Great. Once you get the value of lambda by 6, there is a very small trick. If the path difference is lambda by 6, the time difference would be t by 6. You don't have to sweat much blood here. If the path difference is lambda, time difference is t. If path difference is lambda by 2, time difference is t by 2. If the path difference is lambda by 6, time difference is t by 6. This is straightforward. Do we understand this? Can I have some raise hand? That, sir? Yes, sir, we do understand that, sir. So that I can move ahead, sir. Waiting for your confirmation, sir. Okay. Now we continue on our journey to write the formula of intensity and amplitude. So we are back to square one. We have seen how we can find out the path difference, phase difference, and time difference. We come back to the original formula, and the original formula is the resultant amplitude is A is equal to A1 square plus A2 square plus 2A1 A2 cos phi, and the value of intensity is I is equal to I1 plus I2 plus 2 times I1 I2 both in root cos phi. Now, if we take a very special case, and the very special case is the one that will come to you, if the intensity of both the waves, both the source is same, I1 and I2, we can write it as same I0, then the formula for intensity becomes very interesting. The first way in which you can write this is 2 times I0 into 1 plus cos phi. 1 plus cos phi can be converted into cos phi by 2. It becomes 4 times I0 cos square phi by 2. Please remember these two formulae. If the intensity is same of both the waves, you can write the resultant intensity in formula number 1 in the form of formula number 1 or in the form of formula number 2. Is it clear to everyone? I'll give you a minute to note this down. Then I'm here with a small question. That small question comes on your screen right now. The phase difference corresponding to a path difference of x is what? That means if path difference is x, what is the phase difference? And I'm waiting for your answers. 1, 2, 3, 4. Phase difference is to be found out, and the path difference is given as x. This is how question come, and this is how you utilize what you have learned. So what is the answer? A, B, C, D, 1, 2, 3, 4. What is the answer? Path difference is x. You have to find out the phase difference. What is the answer? Yes. And the answer is a straightforward 2 pi x by lambda. Do we understand this? Well, this is quite clear from the formula that we have already done. And there is no point of me discussing it again because that is not going to make much sense. So what I'll do is I will move ahead in life. We should always move ahead in life, and we move on to the next thing. And the next thing is, where do we get a bright fringe? Fringe means image. Where do we get a constructive interference, and where do we get destructive interference? Now, to understand what is constructive interference or what is destructive interference, see, when I use the word, so you can now write the heading constructive interference, and you can see this word highlighted here, constructive interference, or you call it bright fringe. When two waves intersect, overlap, or superimpose, at some point intensity is maximum. So the point where intensity is maximum is known as constructive interference, or the condition for bright fringe. Do we understand this? Now, this intensity will be maximum. Intensity will be maximum when the value of cos phi, will be equal to +1. Do we understand this? For the value of cos phi to be +1, the angle phi must be an even multiple of pi. The value of cos of 0 is +1. The value of cos of 2 pi is +1. The value of cos of 4 pi is +1. The value of cos of 6, 8, 10, 12, even multiples of pi will always be equal to +1. In that case, I shall have maximum amplitude A1 plus A2, and I shall have maximum intensity root over I1 plus root over I2 ka square. This is what we achieve from the formula that we have already discussed. Yes or no? No, yes. If the intensity of the two waves is equal, I1 and I2 are equal, it is equal to I0. The original formula number 2 that we had seen for intensity is 4 I0 into cos square 5 by 2. For constructive interference, when the angle is 0, 2 pi, 4 pi, 6 pi, and so on, the maximum intensity becomes 4 times I0. This type of interference is known as constructive interference. Intensity is maximum, we get a bright fringe. Amplitude is maximum, intensity is maximum. The formulas are given. Such type of interference is known as constructive interference. I'll give you a minute to note it. So, in the previous case, we saw when we will have bright fringe. If we have bright fringe, will have the opposite for it. Where there is Ram, there is Ravan. Where there is good, where there is bad. When there is dark, where there is bright, there is dark. Do we understand this? Yes or no? So dark fringe or destructive interference is the place where intensity becomes minimum. Do we understand this? Intensity becoming minimum means the value of cos phi becoming -1. And when does the value of cos phi become -1? When we have odd multiples of pi. Cos of 180 or pi is -1. Cos of 3 pi is -1. Cos of 5 pi is -1. 7 pi, 9 pi, 11 pi, 13 pi, 15 pi. Wherever we have odd multiples of pi, the value of cos of phi will be -1. Do we understand this? Here you will have minimum amplitude, minimum intensity. You can also write this intensity as root over I1 minus root over I2 ka whole square, similar to the way that you had written there. Do we understand this? It's written here minimum intensity in the form of square. If intensity of both the source is same, you will have the minimum intensity as 0 and you will have a perfectly dark fringe. And we call this as very good interference. This type of interference is known as destructive interference. Phase difference is odd multiples of pi. Intensity and amplitudes are minimum. Value of cos phi is -1. This is also known as dark fringe or destructive interference. If the intensity of both the sources is same, you will have a perfectly dark fringe. I'll give you a minute to note all this information. And the last part of today's class, we'll be discussing something known as average intensity. I've seen a question come sometimes here. If someone asks you to find out the average intensity, this is the formula for average intensity. Average intensity is I1 plus I2, or you can write it as A1 square plus A2 square. Remember this formula, it's a very, very important formula for average intensity. Also remember that intensity is proportional to the width of the slit. What do you mean by slit? If you have light coming from a slit, small hole, pinhole. Do you understand pinhole? Because this is the pinhole or slit that we will be doing in the class on Monday. Young's double slit experiment. This is the slit or hole from which light passes. Now, if the width of this slit or the size of this slit is W, it is very simple to understand. If the width is more, you will have more light passing through it, and therefore the intensity will be more. This is same as your camera ka lens ka aperture. If the aperture is more light will pass, and therefore intensity is proportional to the width of the slit. So this is the formula that we arrive. I1 by I2 intensity of the slit. I1 is the intensity of the first slit. I2 is the intensity of the second slit. Will be proportional to W1 by W2, width of the two slits, and will be equal to A1 square by A2 square, the amplitudes of the wave which are coming out of those two slits. Do we understand this? Can I have some raise hand that we have understood this? I'll give you a minute to note this final point down for today's class. So I hope you have noted it down, bacha. Well, with this, we come to an end of this class. In this class, we have seen what is superposition of waves. When two waves are traveling, they overlap or intersect each other, and the resultant amplitude A is root over A1 square plus A2 square plus 2 times A1 A2 cos phi. In terms of intensity, it is I1 plus I2 plus 2 times I1 I2 cos phi. Phi is the phase difference between the two waves. If the two waves have same intensity, the formula for intensity becomes 4I0 cos square phi by 2. We all agree on this, yes or no? Well, at some point you will have bright fringe where the phase difference is even multiples of pi. At some point you will have dark fringe, destructive interference, where the phase difference is odd multiples of pi. We have seen that the maximum amplitude becomes A1 plus A2. The maximum intensity becomes I1 plus I2. If both are same, it becomes 4 times I0. I1 plus I2 ka root over I1 plus I2 ka square. So it becomes 4 times I0. Do we understand this? Well, we will start with the same topic. We'll be continuing it in the next class. See you there on Monday, same time. Have a nice day. If you have any doubts, please come up to me. Take care. Bye-bye.